Okay, let's now proceed to method of sections. So we have the steps in analyzing trusses using the method of sections. Now first, determine the external reactions. So after determining the external reactions, you pass a cutting plane to only 3 unknown members and apply the equations of equilibrium. So we have summation of forces horizontal is equal to 0, summation of forces vertical is equal to 0, and summation of moment about any point O is equal to 0. You try to take note that a cutting plane can be passed to 4 unknown members provided that the 2 members are collinear. And then, repeat step 2 until all the required bar forces are found. So, for this problem, let us try to find the forces in members CD and CG. So, this is now CD and CG. So, the first step is to determine the reactions. Now, if you try to take summation of forces horizontal is equal to 0, to the right forces positive, then your A horizontal is equal to 0. Next, summation of moment about point E. Summation of moment about point E is equal to 0, taking counterclockwise moment positive. About E. So, we are getting the reactions. So, let us try to take summation of moment, about point E. Summation of moment about E is equal to 0, counterclockwise moment positive. So, we have your AV. So, A vertical is going clockwise. Now, the moment arm of A vertical is equal to 4. So, this is 4. And then, let's start with this one. Minus 1 multiply this one by 3. This one, minus 2 multiply this one by 2. And minus 2 multiply this one by 1. This has no moment because it passes through the moment center. And this is equal to 0. And therefore, your A vertical is equal to, so your A vertical is equal to 6. A vertical is equal to 6 kilonewton. So it's going up. Okay, so let us try to repeat problem number 1. So if you try to take summation of moment about A is equal to 0, counterclockwise moment positive. So we have your E vertical, multiply this one by 4. So we have minus 1, multiply this by 1, minus 2, multiply this one by 2, minus 2, multiply this one by 3, and minus 1, multiply this one by 4, and this one is equal to 0. Hence, your E vertical is now equal to, so E vertical is equal to 3.7, EV, or that is E horizontal, EV is equal to 3.75 kilonewton. So that is E horizontal. Supposed to be, this is your E horizontal. So we have your E horizontal. Now, summation of forces. Summation of forces horizontal is equal to 0. To the right forces positive. Your A horizontal minus E horizontal is equal to 0. Hence, your A horizontal is equal to 3.75 kilonewtons. So, let's try to take summation of moment. Summation of moment about E is equal to 0. Then we have counterclockwise moment positive. So we have your A vertical is going clockwise, so minus A vertical. Now the moment arm is 4. Then we have plus A horizontal. The moment arm is 4. So we have, plus 1, multiply this one by 3, plus 2, multiply this one by 2, plus 2, multiply this one by 1. This has no moment, and therefore, that is equal to 0. So we now have minus A vertical by 4 plus A horizontal, so that is 3.75 by 4 plus 1 by 3 plus 2 by 2 plus 2 by 1, and that is equal to 0. Hence, the value of your A vertical is equal to 6 kilonewton. So that is now your A vertical. So let us try to determine now the bar force in members CD and CG. So let us try to pass a cutting plane. So you try to take note that only 3 unknown members should be passed by a cutting plane. So we have 3 members in here. So you have your CD, you have your CG, and we have your HG or GH. But we are required only to determine CD and CG. Now, passing cutting plane AA and consider the right portion of AA. So if you try to consider now the right portion of AA, so this is now the free body diagram. So this is the bar force exerted by member CD, the bar force exerted by member CG, and this is the bar force exerted by member HG. Now, because you try to take note that if you try to prolong this one in here, and you try to prolong this one, now they will going to intersect at point C. So they will going to intersect at point C. Now such that this distance up to point G is still equal to 1 meter. It's equal to 1 meter. Now, if you try to take summation of moment about point G is equal to 0, let us try to take counterclockwise moment positive. So your CG and your HG has no moment about point G. Now, again, you try to take note that when you are using the method of sections, you try to find a point where 2 of the unknown members intersect, so that only one member will have a moment about that point. So it is only your CD that will going to have moment about point G. So let us try to resolve the component of CD at point C. So you have your CD vertical. So we have CD vertical, and then this is now your CD horizontal. Now, summation of moment about G is equal to 0, counterclockwise moment positive. So your EH is having a counterclockwise moment about point G. So that is equal to 3.75. The moment arm is equal to 2. And then, we still have, we did consider, so we still have the forces. So we are lacking with forces. So we have a force 1 kilonewton at this point. So that is your 1 kilonewton. And then we also have at point G is now your 2 kilonewton. So this is at point G, that is 2 kilonewton. Now, so we have 3.75 by 2. And then, minus 1, multiply this one by the moment arm 1. Okay, to intersect the moment center. Your CDH also passes through your moment center. So you have CDB is going clockwise about point G. So minus CD vertical, multiply this one by 1. And that is equal to 0. So you try to take note that CD, this is 1, that is 1. Hence, the slope is 1, 1. That is the square root of 2. So we now have 3.75 by 2 minus 1 by 1 minus CD vertical is equal to CD. Multiply this one by 1 over the square root of 2. So it's a vertical component of CD. And that is equal to 0. Hence, the value of CD is now equal to 9.192 kilonewtons. So we get a positive value. Again, the direction of CD is correct. So that is in compression. Next, if you try to take summation of forces horizontal is equal to 0, to the right forces positive. Before, let us try to get your HG. So summation of moment about point C is equal to 0. So summation of moment about C is equal to 0. Again, counterclockwise moment positive. Okay, your CD has no moment because it passes through your moment center. Your CG has no moment because it passes through your moment center. So it will only be your HG. So I will going to resolve HG into horizontal and vertical component. So this is now the vertical component of HG. So this is your HG vertical. And this is your HG horizontal. So we have HG horizontal. Now, moment about point C. So the only forces that will have moment about point C. So we now have your 3.75. So we have 3.75. The moment arm is 2. 3.75. Multiply this one by 2. You have 1 kilonewton is clockwise. So minus 1 the moment arm is 2. And then we have your 2 kilonewtons. So, clockwise, minus 2, the moment arm is 1. And then minus hg vertical, multiply this one by the moment arm, which is equal to 1. And this is equal to 0. hg horizontal passes through the moment center, cg passes through the moment center, and cd passes through the moment center. So we have the sum of this, algebraic sum of this one in here is equal to 3.5 minus hg vertical is hg, the vertical component of hg. Now the slope of this 1, 1, so we have the square root of 2. So multiply this one by 1 over the square root of 2, and that one is equal to 0. So that the value of hg is now equal to, what is therefore the value of hg? 4.95. 4.95 kilonewtons. With a positive value, therefore the assumed direction is correct, and that is in tension. Now, let's try to take now summation of So let us try to take summation of forces horizontal is equal to 0. To the right forces positive. Minus 3.75. We have CG horizontal, okay, plus CG, and then plus CDH, plus CDH, and then minus HG horizontal is equal to 0. So minus 3.75 plus CG plus CDH. But the value of CD is 9.192, the horizontal component. Multiply this one by 1 over the square root of 2. 1 over the square root of 2. Minus HG horizontal, and HG is 4.95. Multiply this one by 1 over the square root of 2. And that one is equal to 0. So that the value of CG is now equal to 0.75 kilonewtons. We get a positive value, therefore the assumed direction of CG is correct, and this is in compression. Now, supposing I will going to pass section AA, the same section, at this time, I will going to consider the left portion of the cutting plane. So, we now have the left portion of the cutting plane, and this is your joint A. So, A vertical is equal to 6 kilonewton, and A horizontal is equal to 3.75 kilonewton. So, this is now the cutting plane AA. So, this is the force exerted by CD, or this is the force exerted by CG, and this is now the force exerted by member HG. Now, if I will going to prolong their line of action, so I'm going to prolong their line of action, this will be your point D. So that is now your point D. So the line of action of CG and prolong the line of action of HG. So this is now your point G. Now, so that this distance in here, so we have now the distances. So we have 1 meter, 1 meter, this is 1 meter, and this one is 1 meter. So this time, I did consider, this is, therefore, the free body diagram of the left portion of the left portion of the cutting plane AA. Now, so if you try to take moment about point G is equal to 0. So summation of moment about point G is equal to 0, counterclockwise moment positive. 3.75 is going counterclockwise about point G. The moment arm is equal to 2. And then next, your 6 is going clockwise about point G. So minus 6. And the moment arm is equal to 3. Plus 1, multiply this one by 2. And then plus 2, multiply this one by 1. Your HG and CG has no moment about point G because these two forces passes through the moment center. So your CD, I will going to resolve CD into horizontal and vertical component at joint D. So this is your CD horizontal, and this is now your CD vertical. CD vertical. So your CD vertical has no moment about point G because it passes through your moment center. So it is your CD horizontal counterclockwise. So that is plus. Okay, so plus CD horizontal. So this is, okay, so a CD horizontal is going counterclockwise. So we have plus CD horizontal, the moment arm is equal to 1. And this is equal to 0. Now, so we now have the algebraic sum of this is equal to negative 6.5 plus CD horizontal. Now, the slope of CD is 1, 1. So that is now the square root of 2. So your CD horizontal is CD. Multiply this one by the horizontal slope over the hypotenuse. That is the square root of 2 is equal to 0. Hence, your CD is equal to 9.192 kilonewtons. We get a positive value, hence the assumed direction is correct, and that is in compression. So, next, let us try to take summation of moment about point J. Summation of moment about J. Point J is equal to 0. So this time, I'm going to consider counterclockwise moment positive. So this is our moment center. A horizontal has no moment. So we have your A vertical is going clockwise. So we have minus 6. Now the moment arm is equal to 1. So this 2 is clockwise. Minus 2, multiply this one by 1. Your 1 kilonewton has no moment because it passes through the moment center. Your Hg has no moment because it passes through your moment center. So we have now your CD vertical is having a clockwise moment. So CD vertical, the moment arm is 2. And then we have your CD horizontal counterclockwise plus CD horizontal, the moment arm is 3. And then plus CG counterclockwise about point J plus CG, the moment arm is equal to 2. And that one is equal to 0. So we have minus 6. Minus 6, multiply this by 1. Minus 2, multiply this one by 1. Minus CD vertical. So CD is 9.192. The vertical component of CD is 1 over the square root of 2. So that is your CD vertical. Multiply that one by 2. Now plus CD horizontal, 9.192. Still, horizontal slope is 1 over the square root of 2. Multiply this one by 3. And then plus your 2CG is equal to 0. So the algebraic sum of this one in here is now equal to negative 1.5 plus 2CG is now equal to 0. So that your CG is now equal to 0.75 kilonewtons. We get a positive value, hence your CG is in compression. Now, you try to take note that when you try to pass a cutting plane to 3 unknown members, what portion are you going to consider? Are you going to consider the left or the right portion? So you try to take note that if you try to consider the right portion, their bar forces are the same when you consider the left portion. Now, you try to take note that you have to consider the portion wherein fewer forces are involved. So for problem number 2, find the forces in members EJ, this is your member EJ, and HJ of the roof truss shown. So first, let us try to determine Y1 and Y2. So, using this similar triangle, we have 10 is to 12 is equal to Y1 is to 4. So, we have Y1 is to 4 is equal to Y sub 2 is 2. That is your Y sub 2 is to 8. So your Y1 in here is equal to Y1 is equal to 10 all over 3, and your Y2 is equal to 20 all over 3. Is 20 all over 3. So I'm going to determine the slope of EJ. So we now have the slope of EJ. So this is now your slope. Now, so that if I'm going to determine now the slope of EJ, this is therefore equal to, so I'm going to draw EJ. Okay, so this is your E, and this, baliktad. This is your E, and this is your J. So let's try to determine the slope. So this one in here is 20 all over 3, and this is equal to 4. So 20 over 3, and that one is equal to 4. Okay, so we have the vertical. The slope vertical is 20 all over 3. If you try to multiply this one by 3 all over 4, so this is equal to 5. So the slope in here is now equal to 5. Okay, so also multiply 4 by 3/4. 4 all over 4. Multiply this by 3 all over 4. And this is equal to 3. So the horizontal slope is 3. Hence, this is therefore the square root of 25 plus 9. Or that is equal to 34. Now, let's try to determine now the reactions. Summation of moment about A, summation of moment about A is equal to 0. We have counterclockwise moment positive. So have your G vertical multiply this one by, G vertical, GV or the reaction at G, GV multiply this one by 1, 2, 3, 4, 6 times 24. So GB by 24. So minus 4 by 1, 2, 3, 4, 5, 20. So minus 4 multiply this one by 20. And then minus 3 multiply this one by 16. And then minus 5 multiply this one by 12. And then minus 4, multiply this one by 8. And minus 3, multiply this one by 4 is equal to 0. Hence, your G vertical is now equal to 9.667 kilonewton. If you try to take summation of forces horizontal is equal to 0, to the right forces positive, okay, this truss is not subjected to any horizontal loads. Hence, your A horizontal is equal to 0. Now, summation of moment about point G is equal to 0, counterclockwise moment positive. So, minus AV, multiply this one by 24. Okay, so plus 3, this one, plus 3 multiply this one by 1, 2, 3, 4, 20. Okay, so we have plus 4 counterclockwise. Multiply this one by 16. Plus 5. Multiply this one by 12. Plus 3. Multiply this one by 8. Plus 4. Multiply this one by 4 is equal to 0. So your A vertical is now equal to 9.333 kilonewtons. So you can check using summation of forces vertical is equal to 0, upward forces positive. So your A vertical, 9.333 plus 9.667 minus 3 minus 4 minus 5 minus 3 minus 4 is equal to 0. So this is 0 is equal to 0. Next, let us try to pass a cutting plane. So we are required to determine EJ and HJ. So let us try to pass an exploratory section or a cutting plane passing through EJ and HJ. So this is the cutting plane. Such that this is now your cutting plane AA. So let us try to consider the right portion of section AA. So if you try to consider now the right portion of section AA, so this is now your section AA. Now, so we have now the forces acting are your DE. So we have your DE. I'm going to assume DE to be in compression. So this is now your DE. So this is your DE. Now, another one is your EJ. So this one is now your EJ. That is your EJ. And another one is your, another one in here is your HJ. So this is your HJ. So I'm going to assume HJ to be in tension. So that is your HJ. Now, if you try to prolong the line of action of EJ and HJ, so that is now your point. So that one is now your point J. So this is now your point J. And this one in here is your point D. So that is now your point D. Now, if I will going to take moment about point E, so this is the load. You try to take note that when you consider the any portion of the cutting plane, be sure to include all the loads on that portion you are considering. So we have your GB, 9.667. We have your 4 kilonewtons. And we now have your 3 kilonewtons. So this is 4, 4, and 4. Now, summation of moment about point E. is equal to 0, counterclockwise moment positive. EJ, about DE and EJ has no moment about point E because it passes through your moment center. So it will be your HJ, which is going clockwise. HJ. The moment arm of HJ is Y2, and that is equal to 20 all over. So that one is equal to 20 over 3. So that's Y2. So we have 20 all over 3. So then plus 9.667, the moment arm is 12. Now you are getting moment. So the moment arm in here is equal to 8. And this one is equal to 0. So that the value of HJ is now equal to 9.20. So 9.20 kilonewtons. We get a positive value, hence HJ is in tension. Next, summation of moment about point G. Summation of moment about G is equal to 0, counterclockwise moment positive. So I will going to resolve the components of EJ at point J or at joint J. So we have your EJ vertical. This is your EJ vertical. And we have your EJ horizontal. This is up to the right. So that is EJ horizontal. Now, moment about point G is equal to 0, counterclockwise moment positive. DE has no moment about point G. So, your HJ has no moment about point G. EJ horizontal has no moment about point G. So it will only be the vertical component of EJ, and EJ is going clockwise. So minus EJ vertical. Now the moment arm is 12. And then we have your 3 counterclockwise, that is plus 3. Maligsurat. Plus 3, the moment arm is 8. And then plus 4, the moment arm is 4. And this one is equal to 0. So, your EJ vertical is minus EJ. Now, the vertical component of EJ is EJ 5 over the square root of 34. This is the slope of EJ. So we have the vertical slope, so that is 5 all over the square root of 34. Multiply this one by 12. So this is the vertical component. Multiply this one by 12 plus 24 plus 16. So that is equal to 4t. So that plus 4t is equal to 0. Hence, the value of EJ is now equal to 3.887 kilonewton. We get a positive value, hence EJ is in compression.